before we can start the calculation. So we are starting with the laws of electrolysis quickly. The laws of electrolysis. I use the word laws because there are two laws, the first and the second law. It is important the student know how to state the law and how to solve questions as regards the law. So the first one is first law. We always say first law of electrolysis, or we can say Faraday's laws of electrolysis. That's the right word to use. Faraday's laws of electrolysis. So first law of electrolysis. That is Faraday's first law of electrolysis. Can you hear me, sir?
Yes, I can hear you, sir.
Okay. So the first law of electrolysis states that, or Faraday's first law of electrolysis states that the mass of a substance deposited during electrolysis, the mass of a substance deposited during electrolysis is directly proportional to the quantity of electricity flowing through the electrolyte. The mass of the substance deposited during electrolysis is directly proportional to the quantity of electricity flowing through the electrolyte. So what that simply means is this. If the quantity of electricity that is passing through the electrolyte is I, the mass of the substance that we deposited will also be I. What you put in is what you get in return. That is for the first law of electrolysis. You can relate it to day-to-day activities for the students. Most of the time, students nowadays see school as scam. They say school is scam, school is scam. But they go to the bank, they cannot feel an ordinary teller, and they say school is scam. Yes. They want to pass exam, but they don't read, and you want to get A's. How is that possible? So let them know it is what they put into life. It is what they will get. You sleep when your mates are reading, you will get the result. You read when your mates are reading, you get the result. The same thing is applicable. The quantity of what you put in terms of current is also determining the mass of what is being deposited. So this is the mathematical expression that M is directly proportional to Q, where M here stands for mass of the substance and Q here stands for quantity of electricity. The quantity here, so let me just put it there, Q equals to quantity of electricity. And the unit for this is coulombs. Or with the capital letter C, that is the quantity of electricity. While M here stands for mass in terms of weight, which is the unit is gram or kilogram, depending on how the question comes. Having said that, it is also important that they should know this, that the quantity of electricity can be calculated using the formula Q is equal to I times T, where I, which is the I stands for current in amps, and T stands for time in seconds. So that means I can rewrite this formula as M is directly proportional to IC, because Q is equal to I times T. Any questions, sir?
No, sir, it's clear.
Okay. Now, let the student know also that when calculating questions under electrolysis, the time must always be in seconds. Examiners are very tricky. They will leave the time in minutes, or the time in hours, or the time in both hours and minutes. So a student who will not pay attention or who is so quick to solve, because some students, I don't know whether they are looking for the first to submit. They will just do one quick solving, just go straight and then apply your time in minutes, and then you get the answer. Funny enough, if it's jam, if you solve with your time in minutes, you will see the option there. If you solve in seconds, you will also see the answer there. So let them also know how to change from seconds or from minutes to seconds. So let's just quickly do this. Changing time from minutes to seconds. And in changing time from minutes to seconds, we'll multiply by 60. Say, for example, easy, convert 45 minutes to seconds. It's interesting to know that some students don't even know how to convert minutes to seconds in SS2.
So the several seconds.
Yes, so that's just it. Let them know how to convert minutes to seconds. It might look so simple, but a student in SS2 don't know how to do it. I'm speaking from my experience in class. Most of them cannot even convert hours to minutes, let alone. So if you are converting hours to seconds, how do we not do that? We multiply by 3,600 or by 60 times 60.
And 60.
Yeah, so original 1 hour to seconds will be 1 times 60 times 60. Or you can simply just tell them multiply by 3,600. So before you go ahead with this, just play around with some examples on this one with the students. Maybe give them some little examples, converting minutes to seconds, hours to seconds, to excite them so that they will have a knowledge of how the calculation will look like when the main thing starts. Then we are done with this first law, but let them also notice that 1 Faraday is equals to 96,500 coulombs. It's a standard unit. 1 Faraday is equal to 96,500 coulombs. That is quantity of electricity to either be measured in Faraday or in coulombs. And if you are converting Faraday to coulombs, is 96,000. 1 Faraday is this. Just like $1 to Naira rate, like that. Link it like that to the students, they will understand it.
But 1 dozen equals to 12 articles.
Yes. So we move on to the second law. Second law of electrolysis, or Faraday's second law of electrolysis. Yeah. The second law states that if the same quantity of electricity is passed through different electrolytes, if the same quantity of electricity is passed through different electrolytes, then the mass of the substance deposited is directly proportional to the chemical equivalent of the ion. If the same quantity of electricity is passed through different electrolytes, then the mass of the substance deposited is directly proportional to the chemical equivalent on the ion. That is for the second law. Most times they don't ask them to state second law. Questions are always state first law, state first law. I hardly see questions on stating second law, but let them also know it. But majorly calculations are centered on both application of the first and the second law. So for this second law, let me ask a little question. What is the charge on aluminium? Can you help me, sir?
Yes, I can hear you, sir.
What is the charge on aluminium?
Aluminium has 2 plus. Am I correct? I don't know if I'm correct.
No, aluminium is 3 plus, sir.
Okay, 3 plus.
Yes. It is copper that has 2 plus.
Plus. That's
Hydrogen, 1 plus.
Plus.
Then
Yes,
maybe calcium, 2 plus. Sodium,
plus.
1 plus. Or just plus like that. So let them also know these various charges. I did this one yesterday under the electrochemical series of cations and anions. These charges are very important. Now, what this simply means is this. It means that 1 mole of aluminium equals to 3 Faraday because of this 3 plus it has here. Yeah.
That's
It
correct.
also means that 1 mole of aluminium is equals to 3 times 96,500 coulombs if you are converting this to coulombs.
Coulomb.
Then again, the relative atomic mass of aluminium is always 27 in terms of gram. This also means that 27 grams of aluminium is deposited by 3,000, 3 times 96,500 coulombs of electricity. The same is also applicable for the rest. 1 mole.
I get it, sir.
Yes. 1 mole of copper is equal to 2 times 96500 coulombs. Which copper is, most of the times, copper is given as 64 or could be 63.5. The question will give it to you. But if you're not given in the question, you can work with 64. So this also means that 64 grams of copper is deposited by 2 times 96,500 coulombs of electricity. And the rest like that. Any questions, sir? Any questions?
No, sir. Sure, sir.
Okay.
I understand that.
Okay, sir. Thank you very much. So next we look at now is what are the likely questions as regards this area? What are the questions I could be asked, or what are the questions the student could be faced? 1, calculate mass. So sometimes you will ask them to calculate the mass of a substance deposited. Sometimes you could be asked, calculate quantity of electricity. Quantity of electricity. And this quantity of electricity could either be in Faraday
Or in coulombs.
Or in coulombs, as the case may be. Again, they could be asked to calculate what mole or what amount. If you say amount, it should always be in mole. Then they could also be asked to calculate current. What is the current? Or what is the time? Any question? Then one more thing again.
No, sir,
they could be asked to calculate volume of oxygen. They could be asked to calculate volume of oxygen.
Okay.
This volume of oxygen will either be in cm cube or in dm cube.
Okay.
And one very funny question that I've only seen once or twice: calculate the in terms of money, they relate it to amount to calculate the amount required to deposit a certain mass of gram in terms of naira. So these are the likely questions students could be faced on calculation on electrolysis. So be that as it may, let us now look at examples critically. Example 1. I'll be dictating it. If you can write, you can as well just quickly write it. So I have the first question here. Let's start from simple to complex when teaching students. It's better that way, so that you will not scare them away and begin to look at it as if this topic is one very difficult area that I cannot understand. So let's start from simple ones, and then we'll build it up from there. Calculate the quantity of electricity. If you can take down the dictation, you can write it down. Calculate the quantity of electricity passed when 0.4 amps flows for 1 hour, 20 minutes through an electrolytic cell. Calculate the quantity of electricity passed when 0.4 amps flows for 1 hour, 20 minutes through an electrolytic cell. Just a minute, please. Let me attend to something. Okay, so welcome back. Can you hear me now, everyone? So said calculate the quantity of electricity passed when 0.4 amps flows for 1 hour 20 minutes through an electrolytic cell. Calculate the quantity of electricity. So you're looking for Q. Remember the formula is Q is equals to I times T, quantity of electricity. Calculate the quantity of electricity passed when a current of 0.4 flows for 1 hour 20 minutes. So if Q is equal to I times T, and the I, which is your current, is 0.4, the time is 1 hour 20 minutes. Now, remember I said your time must always be in seconds. So you have to convert this time. So time in seconds would be, you change this 1 hour 20 minutes to seconds, which could be done alternatively. You can just convert everything to minutes and then multiply by 60. And if you are going to do that, 1 hour is 60 minutes, then plus 20 minutes will give me 80 minutes altogether. Then 80 times 60, or I can do 1 times 60 times 60, then plus 20 times 60. If you get that, this will give me 3,600 plus 2 times this is 12, 0, 0. Add up, that gives me 4800. That is 4,800 seconds. That is my time. So if the time is 4,800 seconds, then multiplied by 0.4, so Q now equals to 0.4 times 4,800. If you have your calculator, you can do that and you will get your answer. Now, when you get your answer, the unit should either be in coulombs or in Faraday, depending on the question. If it's an objective question, you check the unit of your options. If they're in Faraday or in coulombs, then you should know what to do. But in this particular question, they are all in coulombs. So once you multiply, your answer you get, you leave it there. Any questions? I think at this junction, I'll give a little break so that some persons who are trying to join can come in, because I can realize from my end here, seems the network on some persons' end is bad and they are struggling to come in. So let's just give a few minutes so that those persons can come on board before I continue. Okay, so let's go to the next example here. Why those persons who are coming in comes in. All these questions are all WIEC questions as regards electrolysis. So next, let's look at this. What is the quantity of electricity produced when a current of 0.5 amps or ampere is passed for 5 hours 45 minutes. Bracket, I have 1F equals 96,500 coulombs. Then since there are options, let's just give the option 0.1, 0.12 Faraday, 0.22 Faraday, and last option, 1.1 Faraday. Madam Gift, can you hear me? Madam Gift, can you hear me? So that's the question. If you are writing, you can just take some few minutes or seconds to try this, then I can clean and we'll solve it. One or two more examples and we'll call it a day here since the network is no longer friendly for some persons. What is the quantity of electricity produced when a current of 0.5 amps is passed for 5 hours, 45 minutes? 1 Faraday is 96,500 with the options on the board. So what we'll do here is quite straightforward. So I can clean this off now before everyone is done writing. We'll start with Q is equal to I times T. So but I equals and T equals my current is 0.5 amps, if I'm right, 0.5 amps. And the time is 5 hours, 45 minutes. So what I'm going to do is turn everything there to seconds. That becomes 5 times 60 times 60 plus 45 times 60. You do this, that will be 5 times 3600 plus 45 times 60. Yeah. So we can use calculator to solve this. Let me get a calculator. Just give me some few minutes. Let me get calculator so that since we can be on the same page. So sorry, I'm back with the calculator. So quickly, let's just run through this. 5 times 3600 gives us 18,000. So this is 18,000 plus 45 times 60, 2,700. Add that up plus 18,000. I'll give us 20,700 seconds. Remember that we can now say Q equals to I times T, which is 0.5 times 20,700. You multiply that times 0.5 to give me 10,000. So my quantity of electricity now equals 10,350 coulombs. But if you check, the options are in Faraday. not in columns. So I wish my options were in columns, I would have stopped here. But since the options are in Faraday, I will now convert that Faraday to columns, or the columns rather to Faraday. So I will clean this side up. And I'll now write this. 1F, which is 1 Faraday, is equals to 96,500 this. So how many Faraday will I get in 10,350? We cross multiply. That gives me 10,350 divided by 96500. So let's divide that and see what we get. Divided by 96500, which will give me 0.107, approximately 0.11 Faraday. So that is what you will get. Madam Gift, sorry about that. Seems your network was having issues.
Yes, sir.
Yeah. So, but I hope you'll be able to follow me to some extent.
Not yet, sir.
Yes, yes, it is well. So we have done at least a series of examples. We've done 1 or 2 or 3 examples. So we're moving on to another example now. So maybe you pick it up on there. However, I will try as much if we can still send the recorded version of this class. Maybe you pick it up from there.
Okay, sir.
Okay. So 1 more examples or 2 more. I will call it a day. I'm already looking exhausted actually too. So
Well done, sir.
So example 3. A current of 4 amps or ampere was passed through copper 2 tetra others of a C solution. I'll just simply short it CuSO4 solution for 1 hour. 1 hour using copper electrode. What is the mass of copper deposited? That is the question. What is the mass of copper deposited? Then in brackets, you have copper equals 64, that's the relative atomic mass, and 1 Faraday equals 96,500 coulombs. Since it's an objective, let me just put the options just as a guide. We have 64 gram, 32 gram, 7.1 gram, and 6.4 gram. Madam Gift, are you writing?
Yes, sir, but I didn't get the question.
It's on the board, please.
I can't see it.
Okay, a current of 4.0 amps. A current of 4.0 amps was passed through CuSO4. Was passed through CuSO4 for 1 hour. Using copper electrode. Full stop. What is the mass of copper deposited? What is the mass of copper deposited? Then in your brackets, we have copper 64. 1 Faraday equals to 96,500 coulombs.
Okay.
So that is, then you see the options there. So quickly, let's solve. I'm left with 8 minutes to go. And once this is over, I'm not going to come back anymore. Let's call it a wrap for now. If I can finish this, I hope I finish this example before the time goes off. So the first thing to calculate in this question is the quantity of electricity. You calculate quantity of electricity for this question. Mr. Honore, sorry about that. It seems like your network went off.
Yes, sir.
Okay, but you can pick it up from here. So the first thing to calculate in this question now is to calculate our quantity of electricity. So let me clean this off before. So Q equals to I times T.
Okay.
Then your I, which is your current, is already given as 4.0. No, your current is always in amps. That's the unit for current.
Okay, yes.
Then the time is 1 hour. We are not to use that 1 hour. We are to convert it to seconds. So that will be
Yes.
1 times 60 times 60, which gives me 3,600 seconds. So then we can now say Q now equals to 4.0 times 3600. Please, someone with the calculator, you can help us out. What do you have? 4 times 36,000 or 3,600. 4 times 3600. That gives me 14,400. So here will be 14,400 columns.
Yes, 40,400.
So I will clean this up now. Remember, we are asked to calculate what is the mass of copper deposited. Now, if this is a theory question in WAEC, let the student always write this equation out. It's 1 mark in the marking guide. Copper Cu 2 plus aqueous plus 2 electron give me copper solid. It is important to always write this. So this means that 1 mole of copper equals to how many Faraday?
2.
Okay, 2, which is 2 times 96,500. And 1 mole of copper is equal to 64 grams. So 64 grams of copper will be multiplied by this. That gives us what? 2 times 965, or you can simply still leave it. Coulombs. Now, the question now is, if I use this quantity of electricity, what is the mass? So here you now put question mark of copper equals 14,400 coulombs. Then you can now cross multiply and you will get your answer. So once you cross multiply, it becomes 64 times 1440 all over 2 times 96500. You can help us out with your calculator if you go a long way. So just cancel out this, cancel out this. And so that will be 64 times 444. 64 times 144 will give me 9216. So 9216 all over 2 times 965. 1930. So 9216 divided by 1930, which is 4.78 grams. I don't know whether that was in the option. Going by your options there, the options are to 1 decimal place, which is 4.8 grams. So your answer becomes 4.8 grams. Any question?
No, sir. No, sir.
Yeah.
So, but how do you get the 4.8 grams?
You divide. If you
Hello,
cross
sir.
multiply, if you divide, if you cross multiply this times this,
I know that.
54,
I got that.
then divide by this.
Then, but on my calculator, it's showing 0.0407 grams.
No, if your calculator is a scientific calculator, is it a scientific calculator, sir? Or the phone calculator?
Yes, sir.
Okay,
This is a scientific calculator.
Okay, what you do is this. Does it have a function like bracket?
Yes, sir.
Okay, open a bracket.
All right, sir.
Type 64 times 14,400. 64 times 14,400. Then close the bracket. Then divide. Then open bracket again. Open bracket again and put 2 times 96,500. Then close the bracket and press equals to.
Okay, 4.77.
Yes, 4.77 to one decimal place, 4.8. But if your calculator is not a scientific calculator, you do your numerator, put your answer, denominator, put the answer, then divide. I would have loved to do one more. But any other question?
Not from my side.
Sorry?
Say not from my side. I've got to understand.
Okay. Let's move on then. I don't have time again. I'm left with just
It's
2 minutes
clear,
to go. Huh?
It's clear.
Okay, I have just 2 minutes to go, so I think I should stop here. But if you have any question as regards this calculation, you can just chat me up on WhatsApp. I'll give you the solution. But for now, I've done like 3 sessions since 9 o'clock. It's already 12. So let us overplug this. Let's call it a wrap. For the other section, if maybe we might do that again later in the evening for carbon and its compound. Otherwise, I'll leave it for tomorrow.
Thank you, sir.
Thank you very much, sir. You've done great. You've done a lot. It means a lot to us.
I will send this video to the platform as well. So I'll send the other one, the second part, and then this third part. So,
Okay. Thank you so much, sir.
you're welcome, madam.
The one you uploaded to the
Telegram.
Google.
Yes. Have you been able to access
I was
it?
unable to reach it. I was unable to access it.
What is it showing you?
And that maybe I should create a class this thing first.
Do you have a Gmail account? I have a Gmail account. It should take you to open immediately. But let me see if I have another alternative to do it. If I can send the video directly without the link, I will sit back.
It's all right, sir. It's all right, sir. Thank you very much.
Welcome.